Morning, everybody. We are now actually live and about to pull apart the Melty brain. I've got a bit of a different setup going on today, so if I'm looking all the way over here, that is for you. That is looking at chat all the way over in the corner, so don't worry if I'm kind of like staring off into the distance, basically. Hopefully you can all hear me okay and everything. Like I said, this is kind of a new setup, trying to get as much desk space as possible today, because there's a lot of stuff to come out of the Melty brain this morning. So we're going to try and get all of that done. And we're doing this mostly because some of this stuff is quite interesting, or I think it is going to be quite interesting. There was some noise coming out of some of the bearings in one of the weapon systems. I also felt at one point that I think some of the weapon bolts have started to come loose. So that's going to be interesting to see what on earth is going on there. And of course, the top plate really didn't do a good job, basically. I mean, I kind of knew that that was going to be the case anyway. There was a bit of an error in the CNC path when I cut this, so the bolt holes for all of the screws got a little bit messed up. They did hold for a little while, but as you can see, after repeatedly melting, they really didn't hold too well at all. So basically, one screw and a bit of tape was holding the lid on, which is not particularly what you want when you are fighting something that spins at a very, very high speed. Oh, cool. You guys can hear me good. That's great. So we're going to start by actually taking the lid off, because the first thing we really need to do is get rid of the spaghetti that is inside the Melty brain, because, I mean, look, just look at this. It is a nightmare in here, and this is definitely one of the things I want to fix for the next version of this. A couple of people already have said in the comments to make better PCBs to deal with this, and 100% we are going to do that, because there is a PCB in here. It just didn't really solve the spaghetti problem. In fact, if I'm honest, it made the spaghetti problem even worse, because if we have a look at this, wait, that's ESCs, where's my PCB? There it is. Oh, that's right, it's wedged in here because there's so much other stuff that needs to come out as it comes out. Okay. So this is our PCB here, and as you can see, it is part of the spaghetti problem because there's just a whole bunch of little connectors and nothing really sits nicely into this board. It just kind of like, I've got all of these little connectors flowing everywhere from this. Hang on, here we go. It's just a bit of a mess. So I think the next version of this, I'm going to have to do something like rigid connectors on this board. I was kind of trying not to, so that I could pack it nicer into here, but as it turned out, yeah, that just made the mess even worse, basically. And then the other problem we have is this LED. We've got two wires that have like disconnected entirely from the main board, which I'm just going to double check these. No, actually the common didn't disconnect. That's odd, because I thought that the... Wait, did the common disconnect? Oh, yes, no, sorry, the common did disconnect. That's why we didn't get any lights at all in the previous fight, or the very last fight at ARC's October meet, because, yeah, the common disconnected, so the LED had absolutely no power at all. Well, anyway, that's enough about that LED. Let's get more into pulling this thing apart. So as you can see, the battery in here, or maybe you can't see that, I don't know. It's very difficult to see inside this robot, but there is a big gray battery right at the bottom here, and everything else kind of gets tucked in around it. So like there are power cables just here, which need to like wiggle up and out to get them out of here. Everything is just very tight inside, which again, I do want to try and fix for the next version of this, although I'm not really sure exactly how I'm going to do that. It might be a case of putting in a much, much smaller battery. This battery is 800 milliamp hour. Oh, I have put Velcro over the labeling. That's very helpful for knowing what it is. But it's pretty big. It's either 800 or 1000 milliamp hour. And I ran 2 fights in a row back to back off this battery, and it was fine. So that means that this battery is far too big, and when I'm struggling for space as it is, it might be the case that we just put that to the side and never use it again and use something much, much smaller. Although, I don't know, because we do need the current draw off of this to run the YOLO drive and 2 weapons at the same time. So, you know, we'll see, I guess. Yeah. The overhead is slightly out of focus until I bring it up. Okay. What we might even be able to do then is if we just zoom that in a little bit. Does that help at all? Let's see how we go. I will wait for you all to tell me what's going on there. Just bring that down into, maybe into focus a little bit better. This is the first time I have used this particular setup, so there is a bit of a learning process going on here. And then to finish this wiring stuff off, we actually just need to start unplugging everything. So weapon motors can go first, because those are kind of the hardest ones to do. And then drive motors after that. Oh my god, there is so much wiring in here. Definitely a thing we need to fix. Like these drive motors, the wiring off the drive motors is insane. This side motor is coming all the way out to here. That's too much wiring, especially as the ESCs themselves have a bunch of wiring on the end. Like, this is just too much, and it was clogging up the inside of the Melty brain, basically. So we'll fix that in a future version. Cut all these wires down quite considerably. Alright, that's that, and then we need to start unplugging power wiring, because the power harness is actually bolted in. Come on, if I can do this without breaking something. Wow, this one's a tight plug. That's that. Next is the ESCs. That one was easy. That's nice. Alright. There we go. All of our mass of wiring all out of the robot. That's good. Okay, yes. Everything else in there is now bolted in and ready to rock. Cool. Alright, so I think next it's time to get the lid off, and to get the lid off we need to do all of those screws and also the weapons as well. So I'm going to start with the weapons because these are the fiddlier ones. And nothing really fancy here. These are just M8 bolts. So we should be able to just... So I've got the ratchet the right way around. No, I have not. Of course not. Why would I have done that? In actual fact, it's probably set up from actually putting the weapons on in the first place, to be honest. Alright, once we're about there, we can undo these, and the weapons basically just drop out, well, once the bolt is all the way back through. This is the bits I normally cut out of videos, unscrewing all of the bolts, or at least speed up in videos, but we're live right now, so I can't speed this all up for you. There we go. That is one weapon. Oh, yeah. Not sure if that's audible or not. I'll bring this up to the microphone. But there's a bit of squeakiness in this bearing right now, which does kind of imply that there is something else going on with it. But I'm not seeing any cracks or fractures in the bearing. It looks okay. So that's interesting. Oh, but one of these bolts. So we've got 6 bolts around the top here. And oh, that's interesting. Getting lots of grease and stuff out of that bearing, which I did clean these and put machine oil in them, so they shouldn't have that type of stuff going on, which is very odd. But again, these were the first time these bearings were run, so first time running at high speed, they're going to get rid of any other oil and stuff in them, which is mostly why I put the machine oil and stuff in them. The other thing too is that we have the nice little damage from Iron Tooth. Again, really not sure how well that's going to show up on camera, because this is a very shiny part, but there is a nice big shot right there from Iron Tooth, which has kind of bent up the retaining lip, but the actual surface that the belt runs on is okay. There's a little bit of a chip out of it, but it seems to be alright. It seems to have held up okay. Now, one of these was a little loose. And I can't find it now. Oh, it's this one here. That's interesting because these shouldn't be loose. These should, well, I did Loctite them in, but the fact that this is kind of just a little bit loose, it's got some play in it, is kind of worrying. Although, what? If I turn that way to undo it, it goes tight again? That doesn't make any sense. Okay, there's some force that's gone on here. We will take this one apart in a second. We're actually going to finish doing what I was doing, which is taking the weapon system off. Alright, and so that's all of our spaces out of the weapon. Just plenty of little spaces to stack everything to where they need to be. And there's also a belt in here, which, can we get off right now? Yes, we can get off, because there is just a gap in the top here, above that. Let's take a look at what you guys are saying at the moment. Delicious looking spaghetti. Yeah, that's, there's a lot of spaghetti going on in this robot, but, you know, sometimes it looks good, and other times, design flaw is it can be balanced sideways. Yeah, so I mean, balancing on this robot is interesting. I kind of didn't really balance the first iteration of this. I spent a long time sitting there balancing it, getting it exactly right. But previous iterations, including this one that I'm currently holding, I didn't really try and balance it too well, mostly because this wiring spaghetti is ridiculously difficult to balance. The whole point of putting all of the electronics back in the middle was essentially so that I didn't have to balance it super well. The whole kind of plan there was that these weapons are the heaviest thing, and they are so far out that they are the thing that is balancing. Because they are exactly the same, they put the robot mostly on balance, and all of the mass in the middle isn't really going to make too much difference to the balancing. That was the thought. It's possible that I was very wrong about that, and some of my melting problems was to do with balance. Balancing left and right, you are correct. That's not an easy way to do that necessarily. That's something that I probably, if I am going to go back to balancing the robot, I probably should actually get back to like building a jig or something that holds it on the weapon bolts underneath so I can rock side to side and work out a melty balance that way. Or I end up doing something like what they do with like Megabyte, which is have a system that rotationally balances it. So plug it into a system that you spin it around and it tries to work out where the balance point is rotationally, which that would be like the ultimate goal. And I'm pretty sure some of the other people who build Melty Brains do rotationally balance their Melties like that. But I've never done anything like that. And I'm not fully sure how to do it at this point in time. Let's take a look at chat again. We had to get rid of 90% of that wiring with a custom-powered PCB. Yes. So I was just talking about that earlier. There is already a PCB in here. This red tape is the back of a PCB. It holds the brain board and some minor wiring, but it's all signal wiring, because I wasn't super comfortable making a power distribution board, because I was only really just getting into like making PCBs from direct from China manufacturing. So I wasn't really sure their capabilities when I did this. But these days I am feeling a lot more comfortable about this. So this is going to get an upgrade. There is going to be a new version of this. We'll have the brain board on it, and it will also have power distribution, which will basically plug the ESCs directly into the power board with much shorter leads than this. Like, this is a pretty short power lead as it is, but I'm thinking like half this length to plug the ESC directly into the brain board and the power distribution board, and just kind of run it that way, I think. How heavy is the weapon and hub? That is a great question, because I don't think I've ever actually sat down and worked that out. So we're going to throw that on the scale right now. This is a weapon with a hub in it. Actually, I'm going to see if I can pull chat up a little bit elsewhere here so that I have another way to talk to you guys here. All right, so anyway, scale has started up. Weapon with hub is 188 grams. So not super heavy in terms of beetle weights. I mean, Annie was rocking a 300-gram blade on its own and then had a hub and aluminium and stuff around it. So probably around 320, 350, I would say. Come on, phone, do the thing. So yeah, these hubs, like these weapons, aren't particularly hefty. They weren't ever designed to be. Most of the energy in this system is supposed to come from the melting, not from the actual weapons. The weapons are there to give it just that little bit of extra punch right at the very end of the hit or the very start of the hit. I'm not sure. The physics of how this thing actually hits somebody are wild, and realistically, I probably am never going to know exactly what's going on with these hits unless I can find somebody with a slow-mo camera that is fast enough to capture this thing in action and capture it hitting, and then we would be able to sit down and actually capture what goes on when a spinner on a spinner hits something, which, I mean, I am personally very, very curious to find out. So at some point, I would absolutely need to go through and find myself someone with a really good high-speed camera, because that would be awesome to go and see, and to see how it all works. All right, let's go ahead and do the next bolt. And while we do the next bolt, I might also quickly have a look at chat again. How are we going? Like balancing a tire, yes, absolutely. So there are tire balances and stuff for cars. Rotational balancing like that is something that I'm not particularly skilled at. It's not something I've really done a lot of before, but I know that it exists. Like, tire balances are a thing, obviously, for your car and so forth. So I need to look into exactly how that type of stuff is done, because that would be very helpful for this type of system. And even to the point of, like, balancing my 3D printed wheels, because I'm sure at a certain point this stuff going fast enough is introducing vibrations, because it's probably not perfectly balanced right now. Well, I'm not even going to say probably. I just know it's not perfectly balanced. Like, infill and stuff in this wheel is going to mean that it is not perfectly balanced, which is probably actually not helping with the whole melty braining thing. Although, you know, a lot of people run custom wheels and things and never have that. Oh my god, I've just seen that. Okay, that's really interesting. We're going to need... Oh, wow. All right, we're going to talk about this real quick first. This is the bolt that I pulled out first. It is actually bananaed. There is a bend here in this bolt. What? That is an 8mm. I mean, sure, it's an 8mm mild bolt, but that is an 8mm bolt. That should not have bent like that. I never bent 8mm bolts on Annie. Not even the mild steel version like this, which I did run in Annie for a little while. I did upgrade Annie to shoulder bolts, which are a hardened steel bolt. And I definitely had never had this type of issue. But, wow. Okay. The fact that we've managed to bend that bolt is very, very impressive to me. Yeah, damn. Okay. Right, yes. So we definitely need hardened steel bolts in the next version. Sure, I was planning on it anyway, but that has solidified that to me. That's ridiculous. I'm not sure how well that's going to pick up on camera. Let's see if I can, like, get this to focus here. Yeah. And see if we can get that to work on camera, because, yeah, damn. And like I said, the banana ring is about here on the bolt, so if you have a look there, it's just bent just that little bit. I mean, enough that I was still able to get it out and get the bearings out of it and stuff, but I was not expecting a bent M8 bolt today. That is amazing to me. Enjoyed the fights a lot. Looking forward to bringing the first robot to a December meet. Yeah, nice. I am always happy to see more people at ARC meets. I am I'm keen to see what you bring. December meet should be another beetle weight fight. So November meet is going to be ant weight A's and ant weight B's, and then December meet should be beetle weights and ant weight B's. Basically the same as what we've just had in the October meet. And then I've found the bearing that has the issue. It is this bearing. It is collapsed in on the side here. If we can get this out. Yeah, there we go. This bearing here definitely took a direct shot. Again, I'm just going to see if I can like focus in on that right here along the front. Again, I'm not sure if that's coming up on camera or not because just on my little preview screen, it looks way too shiny, but it is buckled in across the front here. So that's basically been, I think, directly hit by Iron Tooth, which is not good for a bearing. And yeah, that's very tight. It gets tight. Huh. Okay, it still moves a little bit. It's also, like the other one, expressing just a lot of oil. You can see my fingers at the moment are trashed, but that is kind of to be expected when you work with bearings, especially ones that have been spun at high speed and then hit, apparently. And to go along with that hit, there is also the same damage here, just on the lip of this, this block. Oh, whoa. Okay. Like, these bolts are finger tight. This one, I was sure I put Loctite on these. All right, I'm just going to pull this bolt out because I want to know if there is any trace of Loctite on these. Oh, there is not. Maybe I Loctited one and not the other. Yikes. That is not good. And as you can see, I've got a bit of wiggle. And actually might be able to hear it. Yeah, which is not what you want in a weapon system. So, that one's on me, because that definitely doesn't look like there was any Loctite on that bolt at all. I'm not going to put that bolt back in, because eventually we want to pull that more apart. Okay, I need to be better about my Loctiting of things. Hang on, I'm just going to quickly try all of this again, to try and get chat here rather than there, because it's a little bit more annoying than I was expecting to be looking over here to look at chat. You've got this, if anything, add extra solder to the power copper traces to increase the power. Yeah, so I have seen more recently people doing that, and then also like running wires along the top as well, just like stripping a whole strip of wire and soldering it down to the line so that you can run just a crap load of current through them. So it's that type of stuff that I hadn't seen before and wasn't really comfortable with, but now kind of know what it looks like and how to do it, and I would feel comfortable doing that in a robot these days. So again, we'll probably get onto that for the next iteration of this board, although I kind of want to try and keep the same footprint of this board. If I can move some of the components and stuff around and still manage to get like all the power and stuff onto a board about this size, because this is nice to be able to fit into a beetle weight, whereas yeah, anything bigger than that was going to be a bit of a pain probably. Although we are redesigning this, so I don't know, maybe I design a bigger space for all of my electronics to go in, or a smaller space. I don't know yet. Hopefully a smaller space. If we put that board in and, you know, get rid of the spaghetti, hopefully we can fit everything in a nice, more compact space. That would be really, really good. Yeah, so you wish they'd bring back Robot Wars in the UK. Same. Very, very much same. I think it's unlikely to happen at this point. They brought it back and killed it seemingly on purpose. So I don't think we're ever going to see it back again, which is a real shame, because I really did love Robot Wars. Robot Wars was my first exposure to combat robots. Being an Aussie, I saw sporadic episodes of it when I was a child, and I loved it to pieces. So much so that I actually went to Robot Wars before I went to BattleBots. I went to see a filming, I think, season 9, I believe. The season with the new version of Mr. Speed Squared, the smaller, like lower, squatter, larger disc version, was the season that I went to see. So that was good fun. I mean, I didn't compete, obviously, but I did go. I mean, that was also at the time that I was basically only really just getting into combat robots for myself and actually building things. So, also, one of these, I swear had a hit in it. Yeah, here we go. This belt here also took a shot, but the actual belt is still fine. It just clipped the outer edge. We've lost like a millimeter. But the belt still holds together, still the same shape, still does the thing. So that's not an issue. On the day I saw this shot and I was like, oh, that belt is going to collapse at any moment, but it's rock solid. It's totally fine. All right. Next, we have 6 M4 bolts. These bolts basically hold the top and bottom together because there is almost nothing else holding them together, or at least there wasn't in the previous iteration. In this version, I've also thrown some wood screws in to hold these side paneling, these bits in here, to the base plate, just to help out a little bit, because in the old iterations of this, we were getting some, like weirdness with how things were attaching, because they were literally just friction fit and then these 4 bolts held things together. So when I was taking things apart, it was more often that the walls stayed with the top plate than with the base plate, which I didn't like so much from a repair standpoint. So I was like, well, we're going to fix that by bolting these in. And also it made the whole robot just that little bit more rigid, which was quite nice. Anything that kind of upgrades the robot and helps it stay together, it's always a win in my book. So, like I said, there are about 6 of these, so we'll just get started on these, although thankfully they're not too difficult because the bolts are just about the right size and basically have to be, because otherwise they would touch the ground if I was upside down or something along those lines. I have created a PCB for my bot's ESCs plugged directly into the PCB without needing any power wires, with the only wires being from the battery. Yes. So that type of thing is exactly what I want to do for this going forwards, because that would work. Obviously, does work. You have done it yourself. But it would work in the Melty Brain for sure. So, yeah, we want to do something along those lines as well, just to kind of help out with that whole spaghetti mess idea that we had. Just saying, somebody saying using 4-in-1 ESCs for the Beetle. Yeah, 4-in-1 ESCs are interesting. I could do that, absolutely. I haven't really messed around with any 4-in-1s, but a 4-in-1 would certainly save a lot of space and weight in here. So that would be quite cool, actually. I mean, I've seen people use 4-in-1s before. Steve, the builder of Bunyip, if you've been around on the channel long enough to have seen Bunyip, because Bunyip's been semi-retired for a year now, I think. But Bunyip was running 4 brushless motor drive and was using a 4-in-1 ESC. And I really should have picked up on that, because that saved him a lot of weight and space, which was good because he was running massive wheels that took up a lot of space for him. So I really should have got in on that. I need to actually buy a 4-in-1 ESC and just kind of mess around with it and see how it goes, because I think you can get BO Heli 32 4-in-1s, which is going to be interesting because I need to know how they work with D-Shot, because D-Shot, of course, is the thing that I'm using to run the drive these days. It's basically the only system that's fast enough to run drive for a Melty Brain. Yeah, we'll see how we go. Hopefully we can do something like that. I hadn't thought of a 4-in-1 ESC, and I really should have. There you go. Alright, well, we're through 3 of these bolts. Now, I have countersunk these just a little bit, basically so, again, that the heads go further into the plastic, and again, so that we don't touch the ground with things, because that's an important step, as it turns out, for melting correctly, is not touching the ground anywhere other than your wheels, because as we've seen in the past, you lose, or this particular robot in particular, too many particulars in that sentence, loses its heading when it hits the ground. So that is always an interesting thing and something you want to try and avoid as much as possible. Yeah. All right, we are getting close. 2 more of these M4 bolts to go, and then we should be able to just pull the top off this bad boy. And you can actually have a look inside, which I don't think the inside of this I've really shown too much on camera. The rebuild video in particular, I kind of skipped a step because that video was getting kind of long anyway, and there was a lot of time lapse in it already, so I just kind of skipped over building the inside of this because there's some semi-dodgy stuff on the inside here. I mean, it all works, so it's not that dodgy, but it's fairly dodgy. There's some tape holding in some walls on here, because we've only got 4 walls in here, which should be enough, but we needed gap between those walls to like run wires and things. So there is some gap, and some of it is plugged up with very small HDPE and duct tape, which you will see in half a second here once I get this final bolt out, because this is the last one. Come on. Oh, this is the one that's like jammed right up against the HDPE inside, which is why it's taking a little bit longer to do. Almost there. Yes, there we go. All right. So let's get bolts and stuff out of the way. And then we should be able to very gently peel the lid off, because there are some friction fits on the pegs that hold the sidewalls up. So there you go. That's the top cover. Done and dusted. This version of the Melty Brain, I think I mentioned in the previous video, is slightly longer than the old one, and does actually have bolt holes along the top here, which would allow me to run one of Annie's weapons, which I don't have an Annie weapon nearby to actually kind of show you that. I put them away. I put them in my workshop, so I can't really show you that right now, but that is what that is. Also, wait. That's interesting. If we got bananaed a little bit. Yeah, we've got a bit of bend in the chassis, mostly around these forks here, which I didn't, like the forks that go out over the wheel, which I didn't think got hit. But there's a slight bend in those, so that it's these are the high points here, and those are the low points. So these corners got bent out, like down. Huh. Okay. Well, this is the type of thing. This is why we are doing this. I was not expecting to see flex in the chassis at all, and yet here we are. This is flex in the chassis. Interesting. Now, was that like that before, or was that combat damage? I do not know, to be perfectly honest. Okay. I mean, I didn't think those got hit, but there is a little piece of like plastic here, which does imply that something got nicked at some point by someone. I don't know who would have done that, though. Oh, actually, yes, I do. That would be Lumberjack for sure, because there's a kind of glancing blow on the side there. That's interesting that a Lumberjack managed to hit that and not the spinner, because the spinner sits here. So the spinner should have been the thing that got hit there. Huh. Okay. Not what I expected at all there, to be honest. Let's see. 4-in-1s work well and would be ideal. Yeah, I think I agree. I think that I need to look into some 4-in-1s. I mean, the only real thing at this point that I'm worried about is whether or not they're going to run and react fast enough to be able to Melty Brain. That is the thing I care about the most, obviously. So I need a 4-in-1 that I can D-shot, and I can D-shot quickly, because there are different levels of D-shot. So at least a 12,000 or 1,200 D-shot is something is basically what I want. Because that type of thing runs fast enough to run a Melty Brain. And I also need to make sure that if I was going to run a 4-in-1, that it doesn't have like priority update orders or anything. Because as far as I remember, 4-in-1s are one microcontroller running 4 motors, which could be okay as long as one motor doesn't take precedence over another, because I really need it so that if I say to the ESC, hey, here's a D-shot command, make sure this wheel is going faster. I want it to be going faster now. I don't want it to be going faster in, 10 milliseconds time after it's checked the speeds of the other motors in the 4-in-1 ESC. So that type of stuff is stuff that I would need to sit down and have a look at with the ESCs that I buy. It might even be possible to look it up before buying ESCs, hopefully. Yes, hello to everybody in chat. All right, so we have the lid now off the Melty Brain, and this is what I was talking about with some dodgy stuff going on. So these curvy walls here are really only held in with tape. So if I peel some tape back off of these, which this tape also holds in the motor wires or the spinner wires to stop that from going everywhere. Throw some more tape out of here. Oh, that's interesting. There is dirt and crap all over this tape, which is about where the spinner sits, I would say. So probably more oil and stuff off of those bearings, which we saw before. So there we go. That is one of the sidewalls, which again was literally just taped in, but it was taped in the inside so that the centrifugal force of melting was basically forcing it into the walls and keeping it in place. The tape kind of just holds it for the meantime, but once it's spinning, yeah, it wasn't really going to go anywhere. Also, oh, I have just seen this. So this side, the motor and the pulley are totally fine. These are just 3D printed ABS pulleys. I run ABS pulleys on a lot of my motor side ones because they seem to work well, and this is like a half-hour print. It's something that I can run 100 of them off, or not 100, but a number of spares off, and they survive well enough in a fight to keep going. I mean, this one lasted a whole event and it was totally fine. It's still good, ready to rock and roll. This one, however, definitely looks like it's taken a shot. So you can see some damage here, which all of this damage definitely would be self-inflicted, I would say. This would be my own weapon kind of arcing down, and it's possibly even the one that was loose because that had more flex and play in it, so more likely to, yeah, keep hitting things and damaging stuff. Better than the glitter that I kept finding in my robot for 6 months. Oh, glitter and robots does not sound good. Are you a UK person? Was that was it Shaky that built the ant weight that had twin, glitter tube poppers? Which was wild that was ever allowed into any competition ever. I mean, I kind of like it because it's just a silly, crazy idea, and I am all about those, but oh man, yeah. I mean, I heard about that, and I heard from somebody that it was really, really good at jamming up N20 gear motors, which are unintentionally good at jamming them up, which is kind of funny to me, but also, oh, that would have been such a pain to fight against. The other thing too that's going on here, going back to the robot, I'm not sure if you can see this, but this 1806 is not having a good time. It is starting to wobble on its axis here, which means, yeah, the shaft, which you're not going to be able to see that on camera, I don't think, but the weapon shaft is coming out. It happened at Norwalk. Wait, Norwalk allows glitter? Okay. That I didn't expect. Well, actually, then again, I probably should have. Norwalk seems to allow a lot of things that other places don't particularly allow. It's kind of if you've got a spectacle idea, we will let you run it at Norwalk. So there you go. That's interesting. Yeah. I wasn't expecting glitter at Norwalk, but But yeah, so going back to the robot and the busted 1806 weapon motor, this is the same failure mode that I had on side spin, because these are the same 1806s. I got a batch of fairly cheap 1806s at one point where I've got I don't know, 8 of these or something along those lines. And this is the second one of these that I've had with this exact failure mode. So I'm thinking that these cheap 1806s, not the best in terms of reliability and quality and stuff. So I need to probably stop using them. Although I do have a couple of, well, I have more of them because as I mentioned, I got a whole bunch of them all in one go. So I might run them, but just know that I basically have to check them after every single fight and make sure that they're not doing the rocking thing and having their weapon shaft or the motor shaft come out of them, because that seems to be the common failure mode with these right now, which is very, very annoying. Oh. Hang on, I'm just losing my phone, which I was using to keep up with chat. There we go. Come on, don't do that. Sorry about that. We are now all good, better at least. Okay, so this final wall needs to come out, which this one was actually held on a little bit better because the prongs at the end here hold in around the power switch in here, or the power link system in here, and do grab just that little bit better. And okay. Yeah, so they grab around the outside of that and hold in a lot better, so there is way less tape required for that side than for the other side, which is basically just holding itself on with tape. Although I do have bolt holes and stuff in here that I could definitely have been running if I really wanted to, but I didn't, so that's alright. Like I said, those walls held themselves in fine. The duct tape was good enough, as it turns out, and look, you know, it was a less weighty solution than putting bigger walls in that actually held themselves in place with bolts and so forth, which was a good thing because, you know, 2 spinners and big drive motors and stuff, I was running out of weight in this robot real quick. So, yeah. All right, let's take a look at this. Here we go. Now you'll probably be able to see this. Let me just sort this out, maybe. Come on. There we go. You should be able to see the shaft popping out the end of that motor there now. Yeah, that's definitely the problem. Oh, and now that I've taken this out, the wobble is like really busted. So this motor is probably going in my scrap pile of motors that I will use as donors for something later on. I've just got a bunch of busted ones, because of course I do, because it's combat robots and you always break weapon motors, especially in Antweight when you mount the weapon directly to the motor, which, spoiler for this week's video, maybe something on that coming up later on today. Well, later on today for me, tomorrow for, I'm assuming, a lot of you out there, because a lot of other people aren't actually at Saturday already. It is currently Saturday morning for me, because time zones are a thing. A very painful and annoying thing, but they are indeed a thing. So, then yeah, the other motor, come out of that, totally okay. Nice. I'm going to put that aside and just use that again next time, because that one has worked. We might even just leave it fully set up, because these 1806s are totally fine to run 100 and something gram weapon, especially on, I think I'm running about a 3-to-1 right now. Although I'm thinking that the next version of the Melty, I'm going to run the 1806s, but I'm going to run a 2-to-1 instead. Swap from using these bigger pulleys to running Annie's pulleys, which are a lot closer to the actual bolt spacing, which will push the ratio down and push the speed of the weapons up a little bit, which I'm pretty sure the 1806s will be able to deal with. I mean, I've seen an 1806 run a 50-gram weapon direct drive, so 2-to-1 to 100-gram weapon should be fine. That should work exactly as intended, I guess. Alright, we're almost actually to the end of the Melty Brain. Once we've done that, we will rip the weapons apart real quick, just to double check other bearings and how the fits go and how the bolts have held up inside here, because now that I know we've busted an M8, I have to have a look at the bolts in here, because there's only 6 M5s in there, and Annie managed to break one of those, so I want to see if we've managed to break one of those in the Melty Brain as well. I think the next step is actually going to be to remove all of these wood screws from in under here that are holding these all pieces in place. There is 2 in every single one because I learned a long time ago when I started doing wood screws into HDPE that a single one will hold, but you can wobble them and break them off if you do that. Not that you can do that with these, I guess, because I've got through holes that everything snaps into. But still, just for assurance's sake, I put 2 into all of these, which I didn't actually even CAD them in. I basically put the thing together, sandwiched the robot together, and sat there with a drill and just drilled holes in, because CNCing like 1.5 mil holes, which is what these are, is a little bit of a pain, and I don't have a CNC myself at this point in time. I'm using the a local makerspace one, so doing lots of repeated tool changes and hogging the machine for hours on end to do one chassis, not particularly the way to go. So I do the basics there, and then I run like drill operations and stuff here at home, basically like printing drill guides and things, and drilling by hand, because it makes sense to do that and keep that machine a little bit freer, and keep the people who run the makerspace happy with me, because they're nice people and they run a really cool makerspace. So I don't really want to make them annoyed. But yeah, there you go. These are the walls, and this is what I was talking about with like the pegs. These are square pegs that fit into square holes, so they locate and lock in place quite nicely, which means that, yeah, I probably could have got away with running just a single screw into these, because really all it's doing is keeping the thing down, and any torsional forces and stuff are going into these pegs instead, but I didn't. Instead, I ran 2 screws because that felt nicer. And then, yeah, same thing with the wheels. Huh. I think that got a little bananaed. That's odd. Okay, I'm not sure if this is going to show up on camera, but I swear there's a slight bend to this. Is the bottom plate warped too? We will find out in half a second, because at the moment there are standoffs under here, so we can't actually lay it flat. We will definitely have a look at that, because as the top plate got warped, we definitely want to have a look at the bottom plate too. But the motor standoffs got warped. Now that is an issue, because the placement of the wheels relative to each other is part of the calculation for doing the Melty braining. Currently, we're Melty braining based off of these ESCs. They will give you how fast the wheel is going, or how fast it's commutating between motor pole pairs. Then knowing how many motor pole pairs you have, you can then work out the speed of the motor, or in RPM. Given the speed of the motor in RPM, you can work out speed of the wheel, and then given the distance between the 2 wheels, you can work out speed of the robot, which is how I'm doing that. But as this plate has warped, that means that the distance between the wheels has shifted, probably not by much, probably by like a couple of millimeters, but that is going to be enough to throw off the Meltian calculations to a significant degree, I would say. So that's very, very interesting. It looks like the motor and wheel have pushed out away from the robot, which makes sense. That's centrifugal force for you. We have got centrifugal force essentially warping this plate. Now, I wasn't intending on taking the motor off this plate in this stream, but I think now that we've seen that warpage, we have to. So much so that I don't have the Allen key required to do this, so we are going to do this the very, very dodgy way with a pair of pliers, because that is all I've got to hand right now, and I can't do this because I couldn't do this by fingers, because these are definitely Loctited and were way more than finger tight, although now that I've got them started, we should be good to go. I mean, these plates have been through a number of fights now. These are the same motor mount plates that I was running in the original version of the Melty. I mean, not the original, not the octagonal version of the Melty, but when we moved to this form factor and had this style, these motor plates were the ones that went in. So they've been through 8 fights, I would say, putting the Melty brain up to as high as I could possibly get it in each of those fights. So the fact that they've warped, probably not super, super surprising. But again, just not something I was like fully expecting to see. Again, this is kind of why I did this on camera with all of you, or with those of you out here, because I knew that there was going to be some interesting nonsense going on inside this bad boy, or at least I thought there might be some interesting nonsense going on inside, because normally I just do pull downs like this on my own, off camera and stuff, and, you know, have a look at things and then plan for a new version of the robot, which I then film, obviously, because that is how this works. But no, in this case, I was like, this could be interesting. So we'll have a look together, and I'm glad I did. I found some weird stuff. I hope you guys out there are enjoying the pull down and the weird reveals of stuff that I was fully not expecting to have happen. Let's see. Somebody saying that they were expecting to watch this later and not realizing it was live. Yeah, I don't do a lot of live stuff, so that is fully understandable. Hello and welcome if you are now actually watching and don't have me just in another tab. I mean, I'm pretty sure a VOD of this will be available on YouTube immediately after we finish recording here, because that's mostly how YouTube works. I'm not sure if I've got my settings set correctly for that. I will make sure to do so. What did I just push? No, that's fine. Yeah, I'll make sure that we've got the VOD of this live so that you can watch it out there after we are done here. But yeah, there is like a decent amount of warp to this part. Oh, damn. Okay, we need to strengthen these for the motor mounts. These motor mounts are the 4.5mm HDPE. I think I'm going to strengthen them to 6mm and possibly even add a backing plate on them. Or maybe I'll keep them at 4.5 and just run a 3mm alley backing plate with them as well, just to give them that little bit of extra strength, because that's considerably warped. Damn. Yeah, lots and lots of power in a Melty brain, as it turns out. Thankfully, these wheels and motors are pretty good. So the wheels, obviously, in the fight recap video, you saw that the hub broke out, which again, we need to do something about. We'll probably run maybe a PCB, I'm thinking, around the outside to give a bit of rigidity to the system and to the mounting space here, but the motors themselves are fine. These same motors have been running all the way since the octagonal version of the Melty and have never had any issues at all. So these are probably more about like 10 fights at this point, and way more spin-ups than that, because the spin-ups on this are like, I keep testing this Melty at home in various different orientations and build setups and stuff. So these motors have melted many times, or even just spun really quickly many times, and still holding up, surviving. I don't even know if I've got a spare of these. I probably do need to go ahead and buy a spare of these for when these motors inevitably break, because obviously I've put them through a lot of torture at this point, and they're still surviving. So while I feel myself very lucky that they're still here, I should actually plan for the time when they aren't anymore. Is this one warped as well? Looking like it might be a little. So we're going to do the same thing. We're going to break this one down too. And basically just check all of this, because again, this is what we're here for today, to see what damage has been caused. And yeah, warped motor plates are probably actually the most devastating damage to this Melty, because again, it's going to affect how well it can Melty going forwards, because it like messes with all of the algorithms that are involved. If I was running sensors in this Melty, it would make no difference at all, because the sensors would be the thing giving us our heading location and not the exact placement of the wheels. So as mentioned in the fight recap video, I think adding sensors into the Melty is the next step, and I was thinking I was going to add them in, use them to calibrate everything, and then move on from there. But I'm thinking that given the fact I've got warped motor plates, maybe I do just run sensors forever from this point on. I just need to sit down and work out what accelerometers and stuff are good for this type of use, because MEMS, which is like in-chip sensors, You can flood them very easily. A lot of them don't have very high G rating that they can get up to, and Melty Brains can put out a very, very high G, so you need something that is going to survive the amount of G-force that you can throw at it from melting, basically. And that means either expensive or rare or both accelerometers, which means that they are less likely to like have library support for Arduino and stuff like that. Which, look, I write code for a living. That is what I do for a job. So it's not impossible for me to run with a gyroscope or accelerometer that doesn't have lots of like documentation or libraries and stuff, but it's easier when those things exist. Oh, this motor is a little bit clickier than the last, so maybe I spoke too soon on these being okay. This is a lot freer than this one, so maybe I do need to order those motors now and replace this, because this is just, feels like it's got a hitch in it. There might even just be a little bit of debris in there or something, or maybe a bearing is loosened up, because I'm getting a bit of wobble, which I don't particularly like the feel of. Okay. Well, that's a good another thing to note. I need to replace that wheel motor because it seems to have not had a fun time. I mean, of course it hasn't. It's been spinning a Melty Brain for 2 years, year and a half, something along those lines. God, how long have I been building this Melty Brain? It's been a while, especially for it to not have done super, super well in the past. This motor plate, a little bit warped, not as bad as the last one. This other one was just real bad, but this guy, yeah, not too bad. I can live with that, actually, I think. Well, I can live with this one, not this one. This one warped too much. Enough that, again, it was probably throwing out the Melty calculations. Have you considered more cleatish wheels? It seems like the norm for other Melties. Kind of. I have looked at that style of thing. But for me, at this point in time, the silicon is the best because I am trying to design a robot that can run on any surface, essentially. So silicon is best for everything, like wood surfaces, metal surfaces, painted surfaces. Cleats work way better when you're running them on wood. And the other thing too is that the guys that run ARC, they are volunteers. They run ARC in their free time. They have lives, families, jobs outside of running ARC. So they don't have a lot of time to put into maintenance of the like arena that we fight in and stuff. So putting cleats on and having like damaging the floors constantly basically just adds more work to their plate, which I don't really want to do. Like I said, they're volunteers. They run ARC because they like robot combat. I don't want to throw lots of extra work on their plate. And also changing the floors in the ARC arena is difficult. They are embedded into the frame. They are not a quick swap. It's a case of like flipping the whole thing on its side and undoing a shit ton of bolts to then get the floor off, to then put a whole nother floor on. So anything I can do to not damage those floors, at least not intentionally damage those floors, I'm going to do. Just, keeping the ARC arena nice and being nice to the people who are very nice to me and, run an arena for me to fight in. So we're going to take these skids off as well now because we need to see if this base plate has warped. I'm thinking there might be some warping on this base plate. All right, what else are we saying? Is there a point where carbon fiber is more suited for some parts? Yes, very possibly. I mean, that's also why I was talking about PCBs. As I have been discovering more recently, PCB material is fairly close to carbon fiber in a lot of ways. So throwing some PCB material or carbon fiber down is probably a good idea. The reason I'm saying PCBs over carbon fiber is there are a lot of PCB fab houses, including PCBWay, who sponsors me. And so that means that it's a lot easier to get custom-shaped PCB material than it is to get custom-shaped carbon fiber. Because, yeah, CNC and carbon fiber is dangerous. You need to do it properly, and even then, like I said, I CNC at a local like community makerspace. So if I had my own CNC, I would be fine with, you know, trying out carbon fiber and making sure I was doing things like flooding it with water so that wasn't dust everywhere, and like wearing a mask even then, and doing it in an open space and so forth. But CNCing carbon fiber in a like community space feels kind of bad. Like, I am exposing other people, or potentially exposing other people, to carbon fiber dust. That's not great. So if I had my own CNC machine, I would be doing carbon fiber stuff. And eventually I'll get back to having my own CNC machine. So I might do custom carbon fiber stuff. But until then, custom PCBs in custom shapes to do basically the same job, I think, is where I'm going to go. But yeah, there you go. Yes, carbon fiber, or in this case, custom PCBs, because custom PCBs are fiberglass. So close to the same level of strength and rigidity and stuff as carbon fiber, just not quite the same. But again, a trade-off I'm willing to make to be able to do them fairly cheaply and easily at this point in my life. We're almost there on this guy. Let's see what else is going on in chat. Have I considered shock mounting wheels? Not sure if that's a great idea given the way the motors are mounted, but it could be reasonable. Yes, so I have considered shock mounting the wheels, but again, as I was saying earlier, the placement of the wheels is very, very critical, to the point that actually I've seen somebody implement a Melty brain where, so I'm just going to like very quickly kind of mock this up. So the wheels sat here, right? And I've seen somebody implement a Melty brain where rather than slowing up and slowing down or speeding up their wheels at the right point in the rotation, what they were doing is they had the wheels on an axis that could move in and out, or on a set of rails that could move in and out. So rather than slowing down and speeding up, what they were doing was they were pulling the wheels in and pushing the wheels out to get the same melting effect. Which is a long way to say that wheel placement is super, super critical. So if you shock mount the wheels too well, the amount of wobble and play you get in shock mounting will actually cause a small amount of change in the wheel position. And basically that means you're getting like inherent melting or like inherent drift in your wheel placement, which means in your translation speed, which means you need to compensate that for heading lights and stuff. It gets difficult quickly, essentially. So as much as shock mounting wheels is always a good thing in combat robots, it's something you have to be very, very careful about in Melty brains. I mean, Zap, the 110 kilo version of this Melty brain, has allowances in it for shock mounted wheels. But the way I've shock mounted the wheels, I shouldn't get too much play. Certainly not on the scale of that Melty brain. Like, there'll be, you know, maybe a couple of millimeters play in the wheel position. But considering the wheel distance is like 400 plus millimeters, I think, from memory. It's been a while since I looked at the CAD exactly. That level of play and variance shouldn't be too bad. But here, to shock mount these up, the level of play and variance is going to actually make a very significant difference to the melting and to the heading and everything that gets done. So somebody asked before if there's any warping in the base plate. A little on these fins, actually. Again, it's in the fins out here, which is interesting because I didn't expect any force to be out here. All of these, like, these are basically decorative pieces that I was not expecting to have any real force or damage go through. Which is very, very odd to me. So, I mean, because these are the points where I'm actually, you know, mounting up weapons and stuff. Although I can see, and I'm not sure I'm ever going to be able to see this on camera, but in the holes where the bolts have gone through, I can see threading, which means that in hits, the bolts have impacted the sidewalls and kind of like imparted threads into those. Where did the little screwdriver that I like go? There it is. Because I've just left a bolt in here. Which, oh, that seems to be kind of stuck. Cool, there we go. That popped through. But there we go. That is the base plate. This is the one that has, like, it's a solid piece. This piece is actually just cut into that same part, unlike the previous version where that was bolted down to the bottom. Just saved a bit of weight and a bit of space and stuff, and Velcro to keep the battery in. But yeah, there we go. Base plate done. And yeah, again, better than it was previous, than the top plate was anyway. It's a lot less wobbly and bad. So we're now going to have a look at the weapon systems. I might even zoom down a little further for this because we don't need as much space. We just need about yay much space. CNC carbon fiber is hard on the cutting bits. You need special bits to cut it. Yeah. Also, hi Seaborg, how's it going? Yeah, so you're right. You do absolutely need special bits. I mean, I already take my own bits up to the Makerspace to CNC up there because they usually run much bigger jobs on their CNC machine. It is a very, very large bed CNC, so they run, like, for their own jobs and for a lot of jobs that people do up there, like a minimum of M6 or 6mm cutting bits, whereas some of the parts here, like the outside edge of this was routed with that same M6 bit, but like this part through the middle here and all my bolt holes and stuff all can't be done with an M6. They have to be done. I have I'm calling it an M6, a 6mm. I have my own like 2mm and smaller even bits that I take up so that we can do the fine detailing work. But again, we cut like the outside edges and stuff, all of the big shapes with the M6 or the 6mm. Wow, why am I using bolt measurements for cutting bits? It's morning. Yeah. Well, yeah, so we use the bigger bit for all of the larger shapes and then do the detailing work with the smaller ones. Because, you know, speed on a machine like that is kind of important when there are other people waiting for machine time and bits and pieces. So if I was going to cut carbon fiber there, I would do the same thing. I would bring my own bits up so that I'm not destroying community bits that other people are using, you know, to cut wood and things, which isn't going to damage the bit at all. But as mentioned, I wouldn't cut carbon fiber on a community machine with other people around. That just, yeah, that seems like a bad move, realistically, especially if you want to stay friends with the people who run the Makerspace, which is 100% what I want to do. Okay. So this is interesting. We have a nice black ring of gunk in here. So that means that this bearing, like the other ones that we've seen today, has released stuff out, which means I didn't really clean these well enough. I did soak them for a decent length of time, and then I hit them with a toothbrush and gave them machine oil and hit them with a toothbrush again and gave them a little bit more machine oil and then let that machine oil drain, but there was still the old grease out of there because you can see it has spun out. So maybe I actually need to, as part of my cleaning regimen, add a setup where I can spin bearings at really, really high speed and have that go flying out and get rid of some of the grease that way. Although to do that, I would need a setup where the grease that goes flying is contained because, yeah, damn, otherwise that is going to get everywhere. But that bearing has survived okay. I mean, it was the one embedded under the weapon, and it was not really exposed to anything. So that one was always going to be one that survived. Looking at our bolts here, these all actually look fine, despite the fact that I didn't Loctite them. They look okay. Oh. Okay, I am going to stand corrected on that one. This bolt here, no idea if I'm going to be able to get this on camera, but there is a chip out of, hang on, let's see if we can focus up on this. There is a little chip out of the threads right at the top, which, looking or thinking about how this was positioned, those threads would have been sitting up out of the bearing, or out of the pulley here, because yeah, the way this all works and sits together, there is a little bit of space, which actually this might be the one. Oh no, sorry, that was this bearing. Yeah, I don't know, but some of the bolt teeth or the bolt thread here got flattened, and it looks, to me at least, Yeah, I don't know. That could have been a shot by a weapon, or it could have just been slammed sideways into the bearing. I really don't know at this point. Either way, it has taken a shot. But other than that, these bolts are fine. Didn't bend any of those, which I'm kind of good with. It means that, we need to upgrade this weapon bolt that bent. For those of you who have joined us more recently, we did bend an M8 weapon bolt in this. So these are just mild steel. I will upgrade these to hardened steel for the next version because obviously we need to. But we didn't actually bend any of these, which was great because that means I don't need to upgrade these for the next iteration. Also, kind of implies that the bending actually didn't happen from us hitting something, but probably something hitting us. So most likely Iron Tooth potentially in one of the hits where we've taken big damage on our pulleys. Which is interesting because, look, when Iron Tooth is hitting us and we're spinning at speed, we are still weapon-to-weapon hitting because we are weapon of Melty hitting horizontal spinner of Iron Tooth, but it's not weapon inside weapon hitting weapon, which there is a lot of weapon to pass in that particular sentence. Okay, these ones definitely had Loctite on them or something, which, just thinking about this, these might be difficult to get out, and I did not bring a lighter with me to denature the Loctite, because that is the best way to get Loctite things back out again often is to denature the Loctite with a bit of heat, and if you can get that early enough, I am pretty sure. Yeah, so this is the bolt I was said earlier. I feel like it's a little bit loose, but if I move it, it tightens back up again. Yeah, this bolt is wrecked. We're going to look at that in half a second, but that has just got, that's got a slight bend in it, and the threads are destroyed. Oh, this one. Okay, let's get the bigger screwdriver out. Morning is for snoring. Yeah, it is currently 9 o'clock in the morning here in Adelaide, which is where I am. I started this stream at 8 a.m. my time because time zones are a real pain. Oh, this bolt is bent. I can tell you that right now. All right, we're going to leave that one because if we can get the other ones out, that will be a lot easier to get that one out. Yeah, we've definitely bent bolts in this particular weapon. Oh, I think we might have even bent all the bolts in this one. Oh, damn. Okay, maybe these need to be hardened bolts as well. Yeah, so while I do this, let's take a look what else you are saying. Would offset weapon heights work? Would it double the contact area and more bite? Yeah, possibly. The only thing about that would be trying to get all of that system balanced, which I'm not too sure about at this point. That could be a difficult trick to balance, I would say, because you are effectively, by offsetting heights, you are offsetting weapons based on your center of balance, which will be hopefully middle of the Melty Brain, but also middle of the wheels too. Excuse me. So that could be interesting. You would have to try and make sure that your offset weapons are balanced around the midpoint of the wheels as well, which again could be quite difficult to swing and get to actually kind of work properly. All right, let's just see if I can get this off without damaging this too much more. Yeah, because this bolt in particular, oh, right, okay, that has loosened up a little bit. Maybe I can slide it. No. All right, let's try and get the other bolt that's less damaged out first. Yeah, okay, now that I've loosened that up a little bit, this bolt's coming out better. That's good. In terms of warping towards the center, does that make sense in terms of force distance? If the wheels stay solid, the force will be transferred to the mounting point, kind of like crowbarring the center. Yeah. That is what I'm thinking happened. Yeah, so that one's damaged. That one's damaged. the warping of the drive plate, I am pretty sure happened because there was too much force. Where is my drive plate gone? It bowed outwards towards the motor. So I'm pretty sure what happened is there's just so much force on this wheel, like centrifugal force forcing outwards, that the motor and the wheel couldn't do anything. The wheel was probably flexing as it was, and this bent out in with the force of just spinning, probably. And I mean, repeatedly spinning. That same motor mount has been used since I was using embedded motor mounts like this. So yeah, that's probably just repeated consistent force has very slowly over time bent that. Oh, okay, this bolt is ridiculous. I'm definitely going to need to try and get you a close-up of this bolt because it is stupid. Now, I just want to make sure, though, before we do that this bolt hole, which is the one that came out of, is actually still okay. Because, I mean, it has had a bolt bent in it, and it is just aluminium, so we could have destroyed the threads. It feels a bit tight, but actually okay. Good. We are not too bad on that, although this bolt's a little bit bendy as well. Okay. Probably not my best choice for that. But then, looking at this, so some of the pit marking and stuff is actually from the laser cutting. If you laser cut these discs, which these are hard to see on camera, one side of them has a little bit of a raised lip, and the first time I mounted these together, I put the raised lip into the aluminium part and bolted tight, and as it turned out, that put pot marking in the top face here. So that's kind of that, and then oh, that's interesting. So see this ring that's near my finger? That's actually a grooved in ring, which means that our bearing wasn't spinning like this. It was spinning against the plate, which is interesting because that should have been held in quite rigidly by the gap in the weapon here. Although I guess not. Yeah, it is free to spin just a little bit. Huh. Okay, there you go. So that has done that indeed. So we do need to be more careful with that. Maybe put a bit of packing in here so that the bearing holds a little bit better. So we're not getting grooves cut into our aluminium pulleys. And again, there's that flat that was hit into us by Iron Tooth. Bit of a pain, really. But that is Iron Tooth. Iron Tooth is always a bit of a pain. Biggest horizontal spinner in the league, obviously going to deal the damage. All right, where is my ridiculous bolt? Yeah, there we go. All right, we need to see if I can get a close-up shot of this. While we do this, what else is people saying? Maybe shoulder bolts. Yeah. So, shoulder bolts is what I ran in Annie towards the end. Well, I ran shoulder bolts for a little while, then I ran a custom mount setup, which will run either shoulder bolts or a custom mount setup in the next version of the Melty Brain because that was really, really good. All right, let's see what I can do about getting this into focus and on screen for you all because this is ridiculous. So, please tell me you can see that. It's got like an S kink in it. It's almost like a layer line shift in a 3D print. The bottom of the bolt and then the top of the bolt are just like separated. All right, please tell me this comes into focus here. Somewhere. If not, what we can do is we can put this back on the table and zoom all the way down to it, maybe. I'm not sure if I'm going to have enough zoom to do this. Could I countersink the bearings into the pulley to reduce the load on the bolts? Yes. Yes, possibly. I possibly could indeed do that. In fact, in Annie, all right. Oh, no, we are at full zoom here. Damn. I might need to take a photo of this and put it like on Instagram or on a community post or something because it is just wild to me. This isn't even really a bend. Like I said, it looks like a layer shift that you would get in a 3D print if your bearings and your belts were bad. That's just It's possibly the most bent bolt that I have had in my hands at any time. Like I said, I'm really, really hoping that you can see this because it is just silly. Let's see if I can, like, hang on. If we put it in here, does that work better? I'm just trying to get the camera to focus on it is the big problem right now. It's really not wanting to. There we go. Hopefully that works. Will it roll? Yeah, I mean, not really. If I... Okay, it does still roll. Because, but it kind of like... Yeah, it wobbles around all over the place. Mostly because it's got this kind of like S-shaped curve in it now. It will actually still roll. It's just that the bottom of the bolt is off axis from the top of the bolt, which is kind of crazy to me. That is the most damage I've seen in a bolt ever. Including from Annie, even when Annie was running like the disc and stuff and hitting the absolute hardest she ever hit, she never did something like this to a bolt. So that's promising. I mean, admittedly, again, it's probably an Iron Tooth versus us hit, and it may even have been that particular hit there where it, like, Iron Tooth has flattened off part of my pulley and destroyed the top, like, lip that catches the bearing, the belt and stuff. So I'm probably going to have to sand this away so that it doesn't cut into the belt from here on out. So, you know, it's probably a case of two weapons hitting, dealing significant energy into the system, because there's a couple of other bolts that are a little bit bent, none of them as cool and S-shaped as that one, which I'm going to keep that bolt for a while, I think, because that's very, very cool. How that has bent and broken is just kind of insane to me. And I'm so glad that I did this on camera with you and you got to see this weird and wonderful bolt, because otherwise I would have like got to this point and gone, damn it, I should have recorded that to put it on a video. But we have now. We've gone and recorded it. Well, done it live and also recorded it. Because, yeah, again, there will be a VOD of this up at some point as long as my settings are set correctly. And if they're not, I will make sure the VOD goes live anyway. But we are actually, I think, probably getting pretty close to the end of this stream. How long have we been live for? We've been live for a little while now. Hour and a half. That's... I mean, kind of short for a stream, as streams go, but, you know, we were here to do a particular job, and we have done that job now. If I zoom back out, my table is just a wreck. I have parts everywhere. I am not a type of person that disassembles cleanly into neat piles, as you can fairly obviously tell here. Oh, we've got one more bit to do. We have the last bit of spaghetti attached to the very last upright, which this upright seems to be okay. I don't see any real warping or anything on it. I'm not sure if I'm going to continue with these. So these are my own custom link system. It is 3.5mm banana plugs sat into some TPU, so really nicely shock mounted. But that does mean that I need custom links. And at the October meet, I messed up and I didn't bring any of my custom links. So I had a fight called and suddenly went, oh no, I do not have a power link that I can use. So I madly went around asking people if they had spare 3.5 plugs. Somebody had some spare 3.5s attached to a motor, so I had to cut them off, solder a plug together based on those, and then use that for the entire event, which... was not good. I mean, I've run these in both the Melty and Annie for a little while now, so I should have more of them around the place, and I don't know where they've all gone. I had about 8 of them at one point, and now I've only got 1, and again, I didn't bring it to the meet, so I guess I've actually got 2 now, because the one I hastily made at the meet also does exist. We're going to zoom back down a little bit so you can kind of see what I'm doing here. It seemed like a good video header. Yes, I might even change the thumbnail of the VOD from the damage to the wheel to the damage to that bolt, because that is very cool, and I like that a lot. So we might even just do that, as long as YouTube lets me. Again, I don't stream all that often, so how VODs and stuff work is not something that I'm like super up to date on. Yikes, that's nasty. It is indeed. Really like the high-speed camera idea. Yes, I want to get the Melty onto a high-speed camera at some point. My big problem is that I'm in Australia. High-speed cameras, I mean, if they exist, I don't know about a lot of them. I don't think there's any, like, big YouTubers or anything, or at least YouTubers of the size that would talk to me. Like, I know that there are some people in Australia with high-speed cameras, but they have subscriber counts in the millions. They're not going to want to talk to me about anything. But if I can get myself access to a high-speed camera, I've been thinking like my old university might have a high-speed camera, so I've got options, I think, on getting a high-speed camera. But a high-speed camera with the Melty would be incredible. Watching that hit something in slow-mo, it's going to be A, really good footage, and B, I'm going to learn so much by watching the dual spinner Melty hit things in slow-mo, because I've never seen that before. Nobody has. I mean, I'm pretty sure people have seen Melties hit things at high speed, like on high-speed cameras, but realistically, a Melty is no different from a spinner when you get down to the brass tacks, whereas spinners on a Melty is very different to just a spinner. So it would be very interesting to watch that on high speed. The ultimate goal would be to find somebody who has like a really high-end high-speed camera. So they've got like 1,000,000 frames a second or whatever, where even at those speeds, even the spinners on the end of the Melty are going to be running at like, 2 millimeters per 100 frames or whatever. That type of thing would be exceptional. That is where you get real data out of it and actually see what on earth is going on with the Melty while it's spinning at ridiculous speeds and having spinning weapons on it. Yeah. Damn. I'm talking myself more and more into just like reaching out to some of the bigger YouTubers I know and being like, hey, I'm a guy who makes robots and doesn't have a lot of subscribers, but this would be cool. I think it's worth it. Just for the shot at getting a Melty brain on a high-speed camera, because damn, that would be cool. Let's see. You've seen double tap. It's an interesting way to have a static weapon that can use the Melty spin to become non-static. I have seen double tap. I am confused by double tap. I've seen photos of it. I've seen the photos that they've put up more recently of it in the pits and stuff, but I haven't actually deep dived into how the robot works or, any of the other material they've put up on it. And it looks interesting. I am a little bit confused as to how their weapon works. I'm keen to see it in the box and fighting because, of course, interesting designs and concepts, like a dual spinner Melty brain, are all well and good until you get them fighting. And it's when they fight that you see how they actually work. So I'm very keen for them to be in the box and be on BattleBots. And, whenever I can watch BattleBots, being an Aussie, I will watch that. And I'm keen to see how that robot goes. I'm also keen to see, what is the robot called? The one that has the arm and the two spinners on either end. Horizon? Maybe? No, I feel like I'm getting that wrong. But I'm keen to see that as well, because if that works well, that is like something I can point to in a new application, be like, look, the Melty brain is going to do a similar type of thing, just at a higher speed and get more ferocious hits than that does. So if it does well, essentially I can basically put in the next application video that we are like that, but with tantrum punches on the end. because we are throwing ourselves into the hits that much faster. Also, I just found an interesting washer that also has some damage on it. It's got a little nick on the edge of it, which, again, probably from Iron Tooth. Thanks, Iron Tooth, doing all of the damage to the robot, which is good, though, because it's stuff like this that lets me know where things are getting hit and what I need to be protecting in the robot. And it looks like, yeah, this whole front weapon system, I need to design it better so that hits on it are weapon-to-weapon hits, probably. Like steel, like hardened steel hitting hardened steel, not hardened steel hitting pulleys and washers and bearings and stuff. Like, none of that is good for the Melty. So we need a better system that allows us to make sure, you know, we're getting these like contacts that are hardened steel to hardened steel. Because Hardox hitting Hardox, I mean, you chunk it out and stuff, but you don't get ridiculous damage doing that. So as you know, we're trying to do the whole weapons are our armor thing. We need weapons that are, you know, cover more space on the robot than 5 mil out of, I think it's 30 odd mil, 40 odd mil height on the whole Melty brain. You know, we're covering like what, less than a fifth or something, or more than a fifth, a little bit more than a fifth, 10th. Something like that. Anyway, we're not covering a grand amount of the overall height of our robot, which means that, yeah, going up against Iron Tooth, if we space the weapons incorrectly, we're just taking shots where we don't want to take shots, realistically. Let's see. Confused by double tap, that is the right response. Yeah. Yeah, it's a confusing looking robot. Would be great to feature with one of those larger channels. Don't show yourself short. Those channels highlight smaller. Yeah. I mean, like I said, if I can get in contact with those type of people and they're interested in talking to me, I would more than happily like fly anywhere in Australia to talk to somebody and yeah, put the Melty on a high-speed camera. So I might start doing that. I might start this weekend, find some people to reach out to and be like, hey, I've got a cool robot, and, you know, maybe I can come and build you robots or something if we can also do a video on my channel where I use your high-speed camera to watch my very, very crazy robot do very, very crazy things. Yeah. Again, I think that might be a thing that we do. Horizon. Cool, I did get the name right. Cool. Metal caps on the end of the arm. Yes, that is a thing I've been thinking about. I was thinking about, with these new bolt holes that we've got, I could put metal caps on the end, which would actually become almost teeth for the Melty brain itself, and also protect the pulley and stuff. But again, I'm in two minds about that. I'm going to zoom back out a little bit. I am in two minds about that, because putting teeth on, they will become, like, putting caps on, they will become teeth on the Melty brain. And while I'm testing this whole thing out, I am kind of trying to have the damage ideal be from the spinners and not from the Melty itself, because Melty damage is a known thing. Like, people know that Meltys deal a ton of damage on their own, just being a Melty spinning around with metal teeth on them. So, by not having metal teeth on here, what I'm trying to do is any damage that is getting done is being done by the spinners, so I can see how much more and or less I'm getting by throwing spinners on the outside, because at the moment, it's still not fully proven that adding the spinners to the outside is actually dealing more damage than just having static metal teeth. So, although one day I probably will try that, I'll probably like run 2 chassis and have spinners and have non-spinners and just hit like a massive block of HDPE or something and see what like damage and knockout and stuff I get out of that. That actually would be an interesting test. The more I think about the Melty, the more I'm like, oh, this would be a cool test to do, and this would be a cool test to do, and this would be a thing that we could do. And it's just a case of time. Like, I fight every month and I'm fighting different robots all the time, and I'm running a YouTube channel, so I don't have time to do every test I want to do under the sun that would make this Melty insane, or maybe just waste time and chase perfectionism, which is not a thing that you should do, because if you keep chasing a perfect design, you will never build a design And, I much prefer to build something that kind of sort of works, put it into the arena, have it take damage, have it mess up, have it, perform at some level and see how that goes, and then go, right, I know what I need to fix, or I think I know what I need to fix, and make changes in a direction and, see if that makes a difference. Because, in this case, I have pushed the weapons further out, and I've realized that MOI problem is a thing. So now we're going to push the weapons further back in, or we're maybe going to try single tooth or something. Still haven't decided on that yet. We will get there. Although I do have a very cool idea in mind for the shape and what we're going to do if I go to a single weapon design, or at least for the heavyweight design, because whatever the beta weight does, the heavyweight will mimic in some way. And kind of vice versa. I mean, this shape and design was done based on Zap, because I did the Octal first and then realized the Octal wasn't great, then designed Zap, and then was like, well, we'll push that down into the beta weight scale. And, here we are, although this isn't as frilly and pop arty as Zap is, because, of course, Zap is designed to be on TV. Whereas this is designed to prove the concept, basically. And because, I know you guys are going to still be interested in watching a robot that looks like this, whereas, BattleBots wants the frill and the comic book stylings and all of that fun stuff. Which, again, I like those things, but, when it's a case of, do I get the Melty to work, or do I get the Melty to look good in the first instance? Because this is what this is. This is a first instance Melty spinner. We're going to get the Melty to work first, and then we're going to make it look good for TV. Right, what else is going on in chat right now? Instead of teeth, could do wedges, feed into the weapon. Oh, that's a great idea. Wedge kind of Tazbot style, wedge to the front to feed into the weapon. Oh, sorry if that was just very loud. That's a cool idea. I like that a lot, actually. Having feeders into the weapon. Melty wedges. That's an idea. That is definitely an idea. I'm not sure how I'm going to incorporate that yet, but I like it. I like it a lot. Cool. And I think, by the way, on that note, I think we are going to end this stream. We have successfully destroyed my Melty brain, learned some interesting things, found some interesting damage, and I think I'm ready now to start work on the new design, or 2 new designs, because I'm still kind of thinking which way I go. So I might start down both tracks, one of the shortening and one of the single toothing, and see how we go on that, see how things lay out and pan out in CAD, because that will kind of help me decide which way I want to go necessarily. But I've learnt a decent amount by pulling this down. And thank you for coming along on this journey with me. I hope you have enjoyed sitting here and, letting me ramble at you and pull down a robot and talk to you about fun things and new robots that are going in. This has been fun. I do need to do more streaming, although I need to do a better streaming setup next time, so I'm not looking over here to look at chat. I need to have something in my field of view that I can look at chat with, because that's a little bit better. But again, this is a slightly newer streaming setup. It's worked, I think, pretty well. Hope you have thought the same. Having the overhead camera has been really nice on a bigger table. The last time I streamed, I was streaming off of my computer desk, and it didn't work quite as well. So yes, I'm seeing first couple of messages of goodbye coming through. So this is where we're going to sign off. Thank you very much for watching all of this. And there will be a video out tonight, which is going to be good fun. Make sure to check that out. And I will see you in the next stream, I think. We're going to do some more streaming. So yes, in the next stream.